Hi, this is Mr. Ward, and in the last week or so, you've learned about a simple linear equation in the form of y equals k times x, where k is some number that you're multiplying x by to get y, and it works if you are going through the origin, you're going through 0, 0. So like if I said y equals 3x, that would be all points where y is 3 times what x is. And it goes to the origin because 0 is 3 times what 0 is. So that works for things like that. But then you also may have learned about, you hopefully learned about the slope-intercept form, which is a different form, where if we had to figure out what the slope is of the line, and then you have to figure out where it goes to the y-axis. So let's say instead of y equals 3x, we have y equals 3x plus 2. That's a line that has a slope of 3, up 3 over 2, and it goes through the y-axis at 0, 2, because this is, of course, the y-intercept at 2. When x is 0, y will be 2, because 3 times 0 will be 0, and 0 plus 2 will be 2, and y will be 0 when x is 0. I'm sorry, y will be 2 when x is 0. Sorry, long day. At any rate, this is the slope-intercept form, and you'll usually see it in the form y equals mx plus b, like that. So y equals mx plus b, where m is the slope and b is the y-intercept. All right, but what about situations where you don't have a y-intercept? What if you have a couple of points out here in the boonies, like here's 3, 8, and here's 9, 5, and we want to come up with a line that goes through them? Well, coming to the rescue is something called the point-slope form, which has a very creative name of point-slope form. You guessed it, because it's about a point and a slope. Now, the point-slope form simply takes the slope equation. So here's the slope equation. Slope equals change in y over change in x. Now, you might notice that I gave it a y1 and an x1, and that means I'm actually talking about specific values. And I left it more general, so it could be an equation for an infinite set of xy points. So instead of putting a number here, I just put an x and a y. Now I have this equation will work. This structure will end up working. Well, let's just rearrange it a little bit. But this structure will end up working as long as you can figure out the slope and you have a point. Now, if I have 2 points, I can find the slope between those 2 points, because I can do, okay, the y change. So that's y. There's an 8 and there's a 5. Those are my y values. So here's my change in y. 8 minus 5. And then doing my subtraction in the same direction, using the same point. So here's my point that I started with. So I did 8 minus 5 for the y change. And now I have to start with this point again for the x change. So 3 minus 9 in the denominator. So 8 minus 5 over 3 minus 9. And I'm going to end up with negative 0.5, which is the same as negative 1/2. Now, I'm just going to make note of that. So slope for this equation is 0, negative 1/2. Okay, we know that to be true based on what we just calculated. However, how can we take advantage of this and make a line equation for this? Well, you might notice that this x minus x1 is in a denominator, right? Well, we could rearrange this by multiplying both sides by x minus x sub 1, okay? And we'll multiply this also by x minus x sub 1. And what we're going to end up with is this x minus x sub 1 in the denominator and this x minus x sub 1 in the numerator, okay? They cancel each other out. So that becomes a 1, and that becomes a 1. And we don't care about a 1 in the denominator. So now we're left with y minus some known y value equals slope times x minus some known x value. Now, I'm going to just rearrange it a little bit more. I'm going to copy this. Okay. I'm going to put it over on the other side, like that. And now what this says is y minus a known y value equals slope times x minus a known x value. Let's see how that would work. So this x and y are some point that we want on the line, and this is the slope for the line we want. So I'm going to get rid of that because we don't need that. So what I'm going to say is y minus, well, let's pick a known y value. Let's try 8. 8 is a y value that we want. Okay, so minus 8 equals, and then we have a slope of negative 1/2 that we figured out between those 2 points. And I'll say x minus a known x value. We're going to use the same point, and the x value is 3, and it goes through both points. Okay, you may be thinking, well, what about the other point? What about the other point? Why do you use this point? Does it work for this point, but maybe not that point? Well, let's find out. So we're going to replace the 3 and the 8 with the x and y values from this point. So the y value is 5. I'm going to say y minus 5. Over here, I'm going to take the x value, which is 9, and so I'm going to say x minus 9, and it works again. Cool. All right, so that works. All we needed was 2 points. We could figure out the slope between those 2 points, and then we pick one of those points to be the x1 and y1, and we are able to make a line that goes through those specific 2 points. All right, I'm going to create another scenario with a different set of points. Let me turn that off, and now I'll turn the other ones off as well. Get rid of that. We don't need that right now. Let's pick another couple of points. Actually, let's start with just 1 point. How about negative 2, comma 3? Okay, there's that point. We'll give it a label. Now, let's say we know the slope of the line we want. We want the slope of that line to be 4/3, up 4 over 3. So I'm going to say y minus, and I want it to go through this point. So it's going to be y minus a known y value, and the y value we know is 3 from that point. I've arbitrarily picked it, and we want the slope to be 4/3. Okay, so we multiply that times the difference in x. So we did the difference in y minus a known y value equals 4/3 times the difference of x, and the x value at that point is negative 2. I'm going to say x minus negative 2. I could, of course, then call that x plus 2, but before we deal with that, let's check it out. Oh, it went through this point. Well, what if we want it to not go through just this point, but also to go through 3/8? Well, if we wanted to go through 3/8, we've got to find out the slope between negative 2, 3 and 3/8. Well, the slope between those points is going to be the change in y over the change in x. Okay, so the change in y, we pick a point to start one for our subtraction. So I'll pick 8 and I'll subtract 3. So I'll pick the 3/8 point. That'll be my beginning of my subtraction. So 8 is the y value and 3 is the other y value. So 8 minus 3. And then I'm going to look at the x's. So I'm going to have to start with the same point. Otherwise, I'll get my opposite slope. So 3 minus negative 2. 3 minus negative 2. And I end up with a slope of 1. So if I want this line to go through those 2 points, I'm going to say I'm going to change my slope from 4/3 to 1. And now it works. Okay, what about if I wanted to go through this point, 9, 5? Well, I need to change my slope again. So if I'm going from, let me turn that off for a moment. If I'm going from negative 2, 3 through 9, 5, I'm going to get the change in y. 9 minus, I'm sorry, 5 is my y value and 3 is my x value. So I'm going to say 5 minus 3. And then I'm going to have to use the x value, I'm sorry. Let me back up. So I started off with the change in y, 5 minus 3. Now I'm going to use the change in the x, 9 minus negative 2. So I'm going to replace that with 9. So it's 9 minus negative 2. And we end up with 0.18 repeating, which you might recall is 2/11. And And we could sort that out pretty quickly. 5 minus 3 is 2, and 9 minus negative 2 is 11. And so, yes, we get 2/11ths as our slope. And so I'm going to replace this with 2 over 11. And let's turn it on and see if it works. It does. It goes to those 2 points. If I wanted to, I could swap out the 3 and the negative 2 and use 9 and 5. So 5 is the y value, so y minus 5, and the x value is 9, so x minus 9, and I get my point. So all you have to get the point slope form to work is the slope you want and one point that you want that line to go through. Sometimes you'll have a point and you'll have a slope, and that's easy. You just plug that in. Put in the slope here, put in the x value and the y value for your points, and set up the equation. It'll work. Sometimes you won't have a slope. You'll have 2 points or 3 or 4 even. Pick a couple of points to find the slope from. And then once you've found your slope, choose one of the points to be the one you want to use in the equation. Either one will do. And you've got it. Now, you probably noticed that sometimes I was subtracting a negative number in there. So beware, if one of the values in your xy point is negative, this is going to be like, if I were using this point once again, I'm going to use, let's see, x minus negative 2 and y minus 3. This could become very easily that, because x minus negative 2 is the same as x plus 2. Either one works. You decide which you prefer. That's a little more elegant, but until you get really comfortable with it, you may want to use that approach. Okay, so there is a whole laser cannon battle commander involved in which you are going to have Earth defense ships going out into the quadrants, and you're going to have to shoot the Belargian fleet out there in the quadrants from ships that are not on the y-axis. So you won't be using slope-intercept form anymore. You'll be using the point-slope form. Now, here's the point-slope form. Let's go into the right spot in here. Okay, that was the slope-intercept form, 5a, and here's the point-slope form. So it's simply y minus a known y value, this is a y coordinate of a point on a plane, equals slope times the variable x minus a known x coordinate of that same point. We'll call this point 1. So point 1 is some number, x1 and y1, and you're just going to replace these with the x and y values of that point that is you need to be on the line. And this is the slope that's going to describe this. This is going to be the number that will describe the slope of the line. Here is the whole thing worked out. Y minus y1 over x minus x1 equals slope. We multiply both sides by x minus x1, so it ends up here, cancels out down here, and we end up with y minus y1 equals slope times x minus x1, and you have the point slope form. All right, I hope that helped, and you should experiment with it with individual points yourself. In fact, I recommend at this time you open up your own Desmos and try it out right now. So just try it out, open up a Desmos, and see if you can make a line that goes through 2, 8, and let's say 12, 3. Okay, and you'll just have to come up with a slope. So you should pause the video. I'll go ahead and walk through this in a second. You should pause the video and do this. So what I want you to do is first find the slope. Okay, I'll assume that you paused and you're back and you found the slope. And to get the slope, you did the change in y. So I'm going to do 8 minus 3, because that's the change in y, over 2 minus 12. And you got this number, -1/2. By the way, it would have worked this way too. Maybe you didn't do that. Maybe you did 3 minus 8. You did 3 minus 8. Will it work this way? Well, let's find out. 12 minus 2, going the other way. Oh my goodness, we get the exact same thing. And that's because it'll work going from this point to this point or from this point to this point. So here we have our slope. Now we want to come up with an equation. Remember, the equation is y minus y sub 1, whatever that number is, equals slope times x minus x sub 1. Pause the video and see if you can create an equation that does go through those 2 points. There are those 2 points right there. I'll label them for you. See if you can do that. And assuming you did pause and you tested it out, you could have done this. You might have replaced this m with -1/2 or -0.5 if you prefer. And then you could have replaced the x and the y, x1 and y1 with the 2 and the 8. Okay, 2. And then 8. And there you have a line that goes through both points. Or maybe you chose 12,3 as the thing. So instead of 8, we use 3 for the y value for 12,3 and 12 for the x value from 12,3. It'll work for either point. The one thing you want to watch out for is this mistake, replacing this y with an 8 and this x with the 2. If you get rid of your variables, nothing's going to happen. It's just a true mathematical statement. 8 minus 3 is going to equal -1/2 times the difference of 2 and 12. That's just going to be true. But it doesn't make an equation that makes it is an equation. It doesn't make a line. So if you want a line, you need your x and your y variables. Okay, I hope this has helped. I'm going to stop, and good luck with this level and also with Laser Cannon Battle Commander level 1.1, the slope intercept form.